So on this question, we have a picture of a graph, and it's labeled right here. The graph is labeled as a function, y equals f of x. And we have two questions related to this picture. The first one says, for how many values of x is f of x equal to -5? So let's think about what these symbols mean for a second. We have to remember that f of x is the same thing as y. So this is saying y equals -5. For how many values of x is y equal 5? So one way we can think about this is to draw a horizontal line. Y equals -5 is a horizontal line. And that horizontal line will be at y equals -5. I'm going to draw it right here. And this horizontal line, if we think about it, every ordered pair on this line will have the y-coordinate being -5. So every ordered pair. Now we're interested in only the ordered pairs that are on the graph. And so we only have this one ordered pair that's on the graph that has a y-coordinate of -5. And so we can say there is one x value in which f of that x value is -5. f of 2 equals -5. Then the second part says, what is the value of f of 6? F of 6, when we look at these symbols, what we should realize is that the number in the parentheses is the value of x. So we know that x equals 6. And f of 6 is referring to the y. So I'm going to draw this time a vertical line at x equals 6. So 1, 2, 3, 4, 5, 6. Here's 6. I'm going to draw a vertical line at 6. And this vertical line represents all of the ordered pairs that have an x-coordinate of 6. But we're really only interested in the ones on the graph in f of 6. So we only have one that's on the graph here. That ordered pair is 6, -1. So that tells us that f of 6 is -1. The y, and I for whatever reason wrote -5 and said -1. So the y is -1 when x is 6. Write the equation in standard form of a circle with center -4, 5 and tangent to the y-axis. So I pulled this from our notes. This is the standard form of a circle. The standard form of a circle is x minus h squared plus y minus k squared equals r squared, where r is the radius and hk is the center of our circle. So we want to write this standard form. We need to know the h and the k, which is the center, and luckily we do know the center, that's -4, 5. And we need to know r, the radius of the circle, to be able to use the standard form. So we know the center, we don't know the radius. But we do have this extra piece of information that our circle will be tangent to the y-axis. So this piece of information will lead us to figuring out the radius of the circle. So what does it mean to be tangent to the y-axis? So I'm going to draw a picture for you over here. When a circle is tangent to the y-axis, what that means is that the circle touches the axis at one point. So we can see here that the circle will touch the axis instead of crossing the axis, and it also means that it's not going to miss the y-axis. So this is a picture of a circle that is tangent to the y-axis. Now, why does this help us find the radius? Now remember that the radius is the distance from the center to any point on the circle. And I didn't do the best job of drawing my circle here. It's not very balanced. But because it is tangent to the y-axis, I know where that center is. That's going to be HK. So this is going to be some value of H. And that is how far, H is how far away we are from the y-axis. And that's going to be how far the center is to this point, that value of H. So that's going to help us figure out the radius of this circle. So let's draw the picture for this circle. We know that the center of the circle is -4, 5. So here's the center of the circle. And because the circle is tangent to the y-axis, I know if I go straight over here to the y-axis, that's the point where the circle will just touch the axis. So then the circle will be something like this. And I'm going to be able to figure out what that radius is right there. So this is -4, 5. So that means that this distance is 4 because my x-coordinate of the center is -4. That's a distance of 4 away from the y-axis. So now I know the center is -4, 5, and I know the radius is 4, and I'm going to substitute those values into the equation of the circle. I've got x minus h squared plus y minus k squared equals r squared. Substituting in the -4, the 5, and the 4, I will have x minus -4 squared plus y minus 5 squared equals 4 squared. And I'm going to simplify this double negative, and I'm going to simplify this exponent, and I have my standard form. X plus 4 squared plus y minus 5 squared equals 16. And we have our standard form of the circle. Determine if the relation is also a function. Give the domain and the range of the relation or function. So the first question says, determine if the relation is also a function. So it might be helpful to know the definition of a function. Okay, so I grabbed a screenshot from our notes of the definition of a function. And here we have the definition being a function is a relation such that for each element in the domain, there is exactly one corresponding element in the range. So the keywords are this exactly one part. So for each element in the domain, that's each x, we have exactly one element in the range, that's the y. So for every x, there is one y. So that's what we want to focus on when we're deciding whether this is a function. So some shortcuts that you can go through is to pay attention to the x-coordinates, and you're going to watch if the x-coordinates repeat. Notice here I've got two ordered pairs with the same x-coordinate. So that is an x-coordinate that is corresponding to a y of 8 and a y of 5. This is one x-coordinate corresponding to two y-coordinates. That violates the definition of a function. So we're going to be able to say that no, this relation is not a function. And then we want to find the domain and range of this relation. We already said it's not a function, so it's a relation. The domain is a set of all x's. So I'm going to create a set that's with curly braces, and I'm going to list the x's. So we have an x of 8, an x of 2, an x of 1. I have another 2. So that 2 is the same as the 2 from earlier, so I don't need to write it again. This 8 is the same 8 from earlier. We don't need to write it again. And this 1 is the same 1 from earlier. So our domain only consists of three numbers, 8, 2, and 1. And then we want to write the range, and the range is the set of all y-coordinates, second coordinates. So for our range, we have an 8. I'm using curly braces, and the items in the set are separated by commas. We have an 8, then a 7, a 1, 3, a 5, and then I have a 3 that's repeated, so I don't need to write that 3 again. And I'll close it with the curly braces. So that's the domain and range of this relation, and the relation is not a function. Classify the given function as a polynomial function, a rational function, a root function, and then find its domain. Write the domain in interval notation. The function that we want to classify is f of t equals the 9th root of 4t plus 1. So this one has a radical in it, and so it's not too hard to classify it as a root function. Roots and radicals are sometimes used interchangeably in math. So when you see a radical, specifically a variable underneath a radical, you have a root function. So this is going to be a root function, but then we want to figure out the domain of the root function. And we categorize the root functions by the index. So we take a look at the index, and the index is either even or odd. Now the index in this example is this 9 here. So that's the number that you see. I'm going to draw my 9 like this. That's the number that you see attached to the radical. And 9 is an odd number, so we know this is an odd root. Now that's important because we find the domain differently based on whether it's an even root or an odd root. The thing to remember here is that if we have an even root of a negative, we get I, which is imaginary or complex number. So in terms of real numbers, the radical is the even root is only defined for positive or 0. However, the odd root of a negative is defined as a real number. So an odd root will have no restrictions. You can substitute positive numbers, negative numbers, 0, any real number into an odd root, and you will get an answer. So for our domain, what we're saying is on our real number line, we're allowed to use any of these numbers to plug into our variable. There's no restriction. So our domain will be the whole number line, negative infinity to infinity. So our domain of this odd root function is all real numbers, negative infinity to infinity. Classify the given function as a polynomial function, rational function, or root function, and then find the domain. Write the domain in interval notation. So without looking at formal definitions, we can quickly identify rational functions and root functions. Rational functions are functions that have a variable in the denominator. That's a very loose definition. It's more technical than that. And root functions are going to be functions with a variable underneath a radical. Once again, that's a loose definition. But if you're quickly trying to identify, you're looking for a variable in the denominator or a variable underneath a radical. Here we have a variable in the denominator. So I'm going to classify this as a rational function. Now, remember I mentioned that rational functions have a variable in the denominator. So that means they're going to have fractions in them. And fractions have sort of this one undefined situation. The undefined situation with fractions involves having a 0 in the denominator. So if you have a non-zero number divided by 0, it is undefined. When we're finding domain, we're looking for where it is defined. So it's going to be good for us to figure out where the function is undefined. So to do that, we're going to take this expression that's in the denominator, and we're going to force it to be that 0 that makes it undefined. So let's take 3x plus 2, set that equal to 0, and solve. I'm going to subtract 2. That gives 3x equals negative 2. Divide by 3, and we get this solution of negative 2/3. So this is our restricted value. It's restricted because if I were to substitute this into the function, it's going to cause the function to be undefined. So let's watch that happen. If I substitute negative 2/3 into this function, I get 3 times negative 2/3 minus 2 over 3 times negative 2/3 plus 2. This 3 that's multiplied and 3 that's divided cancel. Same thing up here. And we get, in the numerator, negative 2 minus 2, and in the denominator, negative 2 plus 2. And then that simplifies to be negative 4 over 0. Because we have a 0 in the denominator, that's undefined. So this number, negative 2/3, is not in the domain of our function because it causes this undefined value for the function. So we have to exclude it from the domain. Negative 2/3 is not in the domain, so I'm going to put an open circle there to say it's not part of the set. But every other real number is a part of the domain. So this is a picture representation of our domain. We want to write our domain in interval notation. So I'm going to write this interval to the left of negative 2/3, and it has a beginning and an end, negative infinity to negative 2/3. You see that I've used parentheses. In interval notation, parentheses indicates that the number is not included in the set. Then I want to represent this interval, which has a beginning and an end. That's negative 2/3 to infinity. Once again, using parentheses because these numbers are not included. And we're going to use our set symbol for union, and that gives us our domain of the function being negative infinity to negative 2/3, union with negative 2/3 to infinity. And just a reminder, this is interval notation, but what does that really mean? That means that every real number except negative 2/3 is part of the domain of this function. Classify the given function as a polynomial function, rational function, root function, and then find its domain. Write the domain in interval notation. So as we've said before, it's pretty quick to identify root functions. They will have a radical in them, a radical over a variable. So we're going to be able to say that this function is a root function. And then we need to get more detailed and focus on the index of that radical. The index is the number here on the radical, and we have an index of 6. So it's important to identify whether that index is even or odd, and this number is even. And the reason why it's important to do that is because we have restrictions on having an even index, but we don't have restrictions on an odd index. So for an even index, the square root of a positive number is going to be defined. The square root of 0 is going to be defined. However, the square root of a negative gives us an imaginary unit of I, and that is a complex number, and it is undefined in terms of real numbers. So we're only looking for real numbers, so we want to focus on these two cases. We only want what's underneath the radical to be positive or 0. So the way that we can figure out the domain of this when it's defined is to take what's underneath the radical and create the inequality greater than or equal to 0. Positive is greater than 0, and then 0 is equal to 0. So that's greater than or equal to 0, taking into consideration the two cases where it's defined. So then we're going to solve this inequality. I'm going to subtract 5. That gives negative x is greater than or equal to negative 5. We're going to divide by -1 to get x by itself. And we need to reverse the inequality symbol because we divided by a negative. So we get x is less than or equal to 5. I'm going to draw this on the number line. We're going to mark 5 with a filled in circle or a closed circle. And we want to shade less than 5. Less than is on the left. And we're going to write this interval in the interval notation. That's -infinity for the lower bound and 5 for the upper bound. On the 5, because this is a closed circle, we're going to include it, so we're going to use a bracket. So on this one, we get a domain of -infinity to 5 with 5 included. On this question, we want to find the center, the radius, and the intercepts of the circle given below, and then sketch the graph of the circle. So the equation that we're given is x minus 1 squared plus y plus 5 squared equals 4. And luckily, this equation is written in standard form, which allows us to find the center and the radius without any calculation. So the standard form is x minus h squared plus y minus k squared equals r squared, where the center is hk and the radius is r. So we're going to be able to recognize the center as being 1, -5. So let's talk about why it's -5. There is a minus in my formula and there's a plus here. So I need to fix that. So I could write this as y minus -5 squared. And now my equation matches the formula. So the number after the minus is -5, and that's our k. So we have a center of 1, -5. And we could also do that with just a shortcut. When you're looking at this, you could just choose the opposite of what you see. So because there's a minus here, you can do the opposite of what you see. That's a -1, so we're going to use a +1 in our center. This is a +5, so we're going to use a -5 in our center. And then over here, the radius squared is 4. I know that 2 squared is 4, so that means my radius is equal to 2. So finding the center and the radius, we really could just recognize it from the equation. To find the intercepts, we're going to have to do some calculation. So to find an x-intercept, we're going to let y equal 0 in our equation right here. So let's take this equation. X minus 1 squared plus y plus 5 squared equals 4, and we'll substitute a 0 in for y. That's x minus 1 squared plus 0 plus 5 squared equals 4. And we'll simplify. That's x minus 1 squared plus, following order of operations to simplify this, 0 plus 5 is 5, and 5 squared is 25. So I have x minus 1 squared plus 25 equals 4. And I would subtract 25 on both sides. And that gives x minus 1 squared equals -21. And then I'll square root both sides to get rid of that square. And the square root and the square cancel each other out, and I've got x minus 1 equals the square root of -21. Now that's going to simplify to I square root of 21. I'm going to add 1. That gives x equals 1 plus or minus I square root of 21. I left off this plus or minus up here. We get that whenever we square root a square. So you might think that I have just found the y-intercept, the x-intercept. However, because we got an imaginary number within our answer, we're not going to be able to graph that on our typical coordinate plane. So because we got an I, we're going to say that there is no x-intercepts. So then let's find our y-intercept. We're going to find our y-intercept by letting x equal 0. So we've got our equation, x minus 1 squared plus y plus 5 squared equals 4. And I'm going to replace that x with the 0. 0 minus 1 squared plus y plus 5 squared equals 4. Following order of operations, 0 minus 1 is negative 1. The rest I'm copying down. Negative 1 squared is 1. And the rest I'll copy down. And I'm going to solve this by isolating the square and everything it's attached to. This is called the square root method. I subtract 1, and we get y plus 5 squared equals 3. I'm going to get rid of that square by square rooting both sides. The square root and the square cancel each other out, leaving you with y plus 5. I get that plus or minus symbol on the other side, and I can get y by itself by subtracting 5. So I've got my y-intercepts being negative 5 plus and minus square root of 3. So I've got no x-intercepts and y-intercept of negative 5 plus and minus square root of 3. So the last thing in the directions asks me to sketch a graph. So I've got a grid here. In order to sketch it, I need the center and the radius. Let me make this a little bit smaller. So we have a center of 1, negative 5. 1, negative 5 would be right here. We have a radius of 2. So I'm going to go up 2, to the right 2, down 2, and left 2. And I'm going to sketch the circle from there. So this is just a sketch. And hopefully this lines up with what you found in the intercepts. So notice that here's my x-axis, and the circle doesn't reach the x-axis, so we have no x-intercept. And for our y-intercept, we do have 2 places where it crosses, and this plus and minus indicates those 2 places. Thank you for checking out my videos. Have a great day.